Hello, welcome to your flame test pivot tutorial. So you will find this in the green week 4 folder in unit 3. So first and foremost, we had a little bit of an issue with this last time. So if you are having an error message appear when you open up this pivot, you can bypass that by hitting these 3 lines here and go to My Classes. And you only have one class, and when you scroll down, you should be able to see the Flame Test Quantitative Analysis Lab. And there will be 3 parts to this lab, and you can complete this right through the Schoology window. The purpose of this lab is to begin to explain why my colored flame demo worked from a few weeks ago, and what ionic compounds contributed to the colors that you saw. So there's 3 parts here. Part number 1 explains to you that I put ionic salts in those Petri dishes when I did my flame test lab, or my flame demonstration. And that's why you saw the different colored flames. And you're going to simulate a different way of doing this by doing a virtual flame test where you would put these salts in a Bunsen burner flame. You will see here that there is a video attached, and this video is to teach you how to use the simulation. You can choose between 2 different compounds. The one that I have loaded is strontium chloride. You'll notice that the word out in front is the one thing that changes, and you can take a look at your periodic table to identify if these are metals or nonmetals. When I load this up, you will see a Bunsen burner appear. You will see Einstein appear. They inserted the salt into the flame. You see a color. And then they're going to add this stuff called diffraction grating. It basically separates a color out into its components. And you will see when the diffraction grating is placed in front of the flame, you will see some very distinct lines appear. And those distinct lines are what you want to pay attention to. So after you have played around with the 2 different compounds in this first video, you can answer the second question and move forward. In part 2, it's the same video, but this time we added what's called a wavelength ruler. The units are nanometers. Nano means billionth of a meter. So imagine cutting a meter stick into a billion pieces. You get to that by hitting the little tool bar here. And this time you've got 4 different ionic salts to choose from, and you're going to do all 4. So I have chosen first sodium chloride, and notice when I load it, you've got the slit placed in front of the flame. Bunsen burner gets lit. And you see this very distinct yellow line appear at the end of the video. Keep waiting for it. Right there, that really bright yellow line, the last thing you see when the diffraction grating is chosen is what goes in front of the flame. And you can absolutely rewind and see that again. And you'll notice that that line happened at about 580 nanometers, because all of these go up by 5s, 590 nanometers actually, because that would be 2 places behind the 600. Record the number that appears last in the video, not the ones in the middle. You might have more than 1 color to record. So to record this, you record 590 nanometers right here like that. This one has an answer lock that's incorrect. This one here should be 590 nanometers. And you repeat this process for all 4 of the salts. The variable that goes in here, you can choose any one you want. I'd put W for wavelength like I did here. There's some questions to answer about that. And then you're going to use that data in part 3. In part 3, you are going to go back to that video that I made with the colored flame demo that we did a long time ago, it feels like now. And you're going to see, based upon the colors that you saw in the lab, the numbers that you collected when you found wavelengths, if you can identify the different ionic salts that I used when I did the colored flame demo. You'll have a link to that demonstration here in part 3, and you can answer that question in this box right below. If you're wrong, no worries. This is, you're interpreting data, first of all, remotely, and second of all, based on your observations. And your observations are your own to make inferences off of. So if you're wrong, but you won't get marked down if your answers are incorrect on this one, unless they're way, way, way off. So that's how we're going to use this flame test pivot. We're going to come back to it again. Instead of saying what sort of compounds create the colored flames that you saw, we'll say why we will learn why in the Bohr's model simulation, why it worked the way it did. So hopefully this makes sense to you, and have a wonderful rest of your day.